Hi, it's a guy Olumide, and today we're gonna be talking about another one of the most commonly asked tech interview question, the linked list midpoint. It's commonly asked by top tech companies including Google, Amazon, Meta, Apple, Microsoft, Netflix, and other top tech companies. The problem statement states that given a single linked list, find and return its middle node. If there are two middle nodes, return the second one. And we can see in this example that is given, we have a single linked list, and then this linked list contains an odd number of nodes. Odd number because it contains 5 nodes, 1, 2, 3, 4, 5, and the middle node is node 4 right here, so we return node 4. So looking at the second example right here, it's a single linked list that contains an even number of nodes, and there are two middle nodes. Because it's even, there are two middle nodes, the node 2 and node 4, and right from the problem statement we asked to return the second middle node if the middle nodes are 2, just like in the case of every even or every linked list that contains an even number of nodes. So they're going to be having 2 middle nodes, and we are going to be returning the second one of the node, which is node 4 in this case as well. The most intuitive approach to solve this problem is to traverse the linked list first to find the length of the nodes, and then traverse it the second time to get to the middle node and to return it. So you understand, it's just like because we can't figure out the length of a linked list unlike an array, so we really need to traverse to find the length, and then dividing the length by 2, we can traverse to find a particular node that falls in the middle. Just like in this case now, traversing the length, we're gonna get the length to be 5, and then 5 modulus 5 divided by 2 is gonna give us 2. When we floor it, it's gonna give us 2. It's actually 2.5, but it's gonna give us 2 when we floor it, and then we can now add 1 to it in the case of odd number. It's an odd number, so we have to add 1 so it can fall right at the middle. So that is quite mathematical. So but this particular solution, though we solve the problem in linear time, but it takes 2 iterations. The first one to find the length, and then another additional iteration to get to the middle. So, and I think there's a more clearer way and better way we can solve this problem in a single iteration. The thing is that when iterating through a linked list, our exact position is unclear. We only know where we are when we get to the end node, the last node. So because at that point there will be no further node, so we can easily get that we've gotten to the last node. And so we create a scenario whereby by the time a pointer gets to the end node, the final node, the second pointer will be positioned at the middle node. Okay, let's consider 2 pointers now, whereby one pointer is moving at half the speed of the other one, and by the time the faster pointer gets to the final node, the slow pointer is positioned at the middle. We can achieve this by using a fast and slow pointer technique, where the slow pointer moves 1 node at a time and the fast pointer moves 2 nodes at a time. So like we have here, we have a slow pointer and a fast pointer at the same position. So the slow pointer is going to be moving 1 step at a time, 1 node at a time, while the fast pointer is moving 2 nodes at a time. And we see that by the time the fast pointer gets to the end, the slow pointer will be positioned at the center, the middle of the node. Anyway, we need to be careful about when we stop to advance the fast pointer. Like right here now, as you can see, this is a linked list of odd lengths, and then we see that we need to stop advancing the fast pointer. Fine, we start advancing it right from the same position, and it moves 1 step, this moves 2 steps, and then it moves one step, the slow pointer, while the fast pointer moves two steps. You see, at this point we need to stop advancing the fast and the slow pointer. Why? Because the slow pointer has now gotten to the middle node. So at the point whereby slow pointer has gotten to the middle node, we need to stop advancing the fast pointer. And you see that for a linked list of old lengths that occur when fast.next is equals to null, meaning that when the fast pointer is pointing at the last node in the linked list. So at a situation where the fast pointer is pointing at the last node in the linked list, the next node will be null. The next node to that fast pointer will be null, because that's the last node, so it has no next node. So, and at that situation you break. So meaning that for a linked list of old lengths, whenever fast pointer next node is null, then it has gotten to the middle the slow pointer has gotten to the middle node, and then we need to break. So for a linked list of even length now, just like this one, 1 2 3 4 even lengths. So fine, they start at the same pace and they keep moving one step at a time, while the fast pointer moves two steps at a time. We see that in a situation, look at this for instance now. Okay, the slow pointer moves one step, fast pointer moves two steps, and you see the slow pointer again moves one step and the fast pointer moves two steps. You understand why? Because first of all, the fast pointer was initially here, and then it's gonna move two steps. So it's gonna move from this 4 to 7, and from 7 again to null. Why? Because it's moving two steps, and then the next to 7 is null. So we say that at that point the slow pointer moves only one step, and right there is at the right middle node. So don't forget, for even number of nodes, we're gonna be having two middle nodes, and we want to return the right middle node. So at the point whereby the slow pointer falls at the right middle node is when the fast pointer becomes null. So and at that point we break. So looking at it now, we see that the two conditions is that once the fast pointer becomes null, or the fast pointer next pointer becomes null. So if this condition is met, we need to exit the loop. So but once the fast pointer is not null, meaning that it is not pointing at a null node, and the fast pointer next pointer is not null, you understand, then we can keep iterating, meaning that once it is around here whereby the fast pointer is not pointing at null, and even its next is not null, so we keep iterating. But a situation whereby it has gotten to this last node over here, and the next pointer is null, or it has gotten to null in fact itself, then we have to break out of the loop. So why do we say this? Is because these are the points whereby the slow pointer will be falling on the middle node that we want, you understand, and we want to break the loop. We want to stop the fast pointer advancing forward at the point whereby the slow pointer is pointing right at the middle node. So, and that's just it. So simple to solve. You will place your slow and fast pointer, because we'll be using the slow and fast pointer technique. So place them at the head node, advance the slow pointer by 1, advance the fast pointer by 2, because if the slow pointer is moving at half the speed of the fast pointer, then by the time the fast pointer gets to the end node, the last and final node, the slow pointer is gonna be at the center of the linked list, the middle node. So, and that's just what we want to apply here. So it's just as simple. We're gonna go into the code implementation very soon, but I just want to tell you that you should like, comment and share this video. You understand? It's gonna be of help to me, right? It's gonna be of help to you too, certainly. If you're looking for a top tech job at top tech companies, visibility is gonna help you get that job. It's really gonna help you get the job. Your recruiter and hiring manager and employees and even employers, they're gonna see you engage with tech content, and they're gonna see you, and they are gonna assume and confirm that you are the one that is fit for the job, because you really are passionate about it, not just building project and creating CVs and tech stacks. You really are sharing your problem and to the world to see. You are solving publicly, you are engaging publicly, and so I want you to do that. So right now, thank you for sharing, for commenting, for following. We're gonna be going to the code implementation now. Alright, let's go into the code implementation for the linked list midpoint problem. Right now we are going to be defining the class for our list node. So this is going to represent each node in our list link. We need, as you can see on the screen, we are going to be creating node 1, node 2, I think node 4, let's see, node 1, node 2, node 4, node 7, and node 3. So let's define the class for that. So def init, and then we're taking self, we're taking value. So this quite one of the basic attributes that we need to set for our node. So self.value equals to value, and we're going to be setting the next attribute as well to none by default. So is none by default. We can decide to change it. Why we are placing it as none is because imagine the last node now is definitely not going to be having a next node, so we are setting it to none by default. And if we wish, probably want to make it to have a next node, we are going to set it manually ourselves. So right now we have this one set. Now let's define our function, the linked list midpoint. So it's gonna be taking in a head. Don't forget a head node, which is also a list node. So it's an object of list node, and then the return is gonna be returning a list node as well, which is going to be the middle node now. So right now I love to, let's just place a pass here, because I really love to define the parameters we'll be needing the whole structure. So list node of 1, so we are gonna create node 1, so this for node 2, node 4, node 7, node 3. So can now change it node 4. Sorry, it's supposed to be node 2, node 2, node 4, node 4, node 7. Let me check again. Node 4, node 7, and node 3, and node 3. So node 1 is connected to node 2, so we set its next attribute to node 2, and similarly node 2 is connected to node 4. So let's just do that for the rest. So similarly node 4 is connected to node 7, and node 7 is connected to node 3. So fine, we can now call the function print linked list midpoint of, and then we're passing head to it. So now let's write the code implementation. So don't forget we'll be defining two pointers, the slow pointer and the fast pointer now, and they'll be initially at the head node. So while fast, so don't forget we have the slow and fast pointer. So while fast and fast.next. Why we are placing this condition is because don't forget for old we have to ensure that fast.next is not null. In a situation whereby fast.next is null, definitely it has gotten to the end of the linked list, and for old linked list, or for a linked list of old length, definitely the slow pointer is pointing at the middle node. For fast.next to be null, don't forget the the logic we explained. And similarly for a linked list of even lengths, whenever the fast become null, at that point the slow pointer is pointing at the middle node. So that's why I place these two conditions, that while fast is not yet null and fast.next is not yet null, then we can keep iterating. But at a point whereby the fast pointer becomes null and or the fast.next become null, we need to return slow, because at that point slow is pointing at the middle node. So what we do is that we shift our slow one step to the right. Similarly, we shift our fast now 2 step though dot next. So we shift it 2 step. So, and that's what we do. And then we just wait patiently until it's gonna exit the loop, being sure that when it's gonna exit the loop, slow is gonna be pointing at the middle node. So we can just simply print, sorry, here we're not printing here, we're passing in node 1. Node 1 is the head. So that's simply what we are doing here. Let's run the code now. Fine, we have this object printed here, so main.list node does blah blah. So but right now we wanna print the value, so that it can be more representable. Let's run it again. So right here we have 4 printed. You see, we have 4 printed, so that's node 4 and that's correct. So you see how simple it is once you understand the logic. So that's how you solve this problem. I hope you understand it. Follow for more, share for more, comment and like for more. Alright, thank you.